Alright, hello everyone. Today we're talking about integrated math, factoring trinomials. This is practice number 10. Factoring trinomials is the opposite of what we had been doing previously, which is multiplying binomials. So just as an example here, as a reminder, if we're multiplying two binomials, we would first multiply x times x, get x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. The 4x and the 3x combine in the middle to make 7x, so you get x squared plus 7x plus 12. So we're going to be attempting to do the reverse of that. Instead of this being the question and this being the answer, this is now going to be the question and this is going to be the answer. We're going to be looking at trinomials and trying to figure out which two binomials multiply to make them. So there's a couple of rules that if you memorize will make this process a lot faster. And it has to do starting with the back number and the back sign. If the back sign is a positive, then you know two things. Your two numbers are going to add to make the term in the middle, and that your signs are the same. They're either both positive or they're both negative. If you know they're the same, they're going to get whatever sign is in the middle. So notice here that the back number is positive. Same for this one. Back number is positive. Positive, positive. So in each one of these situations, when we go to factor, we're looking for two numbers that multiply to make 6 and add up to make 5. That would be 2 and 3. The signs have to be the same. They're both going to be plus. Next one. Back sign is a positive, so we're looking for two numbers that multiply to make 14, add up to make 9. That would be 2 and 7. Back sign's plus, so they have to be the same sign. They're both going to be negative. Two numbers that multiply to make 30 and add up to make 11 would be 5 and 6. They're going to be the same sign, so they both get whatever's in the middle. This time that's a positive. Last one. Two numbers that multiply to make 12, add up to make 7, or 3 and 4. Signs are the same. They're both going to be negative. Now it's the opposite if the back number is a minus. If the back number is a plus, they got to add to make the number in the middle. But if the back number is a minus, they have to subtract to make the number in the middle. If the back sign is a plus, they got to be the same sign. They'll both be whatever the middle sign is. But if the back sign is a minus, they have to be different signs. One's going to be a positive, one's going to be a negative. The bigger of the two numbers will always get the sign in the middle. So these are going to be different signs because this says minus, and the big number is going to be positive, small number will be negative. This one, for example, going to be different signs, but this time the big number will be negative because that's the sign in the middle, and the small number will be positive. So let's just go through some of these here. X and X. Two numbers that multiply to make 12, subtract to make 3. Well, actually, there are none. 1 times 12, 2 times 6, and 3 times 4 are the only numbers that will multiply to give you 12. And none of these, if you subtract them, will give you a 3. 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1, and this happens once in a while. When we come across one of these, we use the words cannot be factored. We will have to go to a plan B in future situations when we get a trinomial that can't be factored. What about the next one? We've got X and X. Two numbers that multiply to make 21 and will subtract to make 4 would be 3 and 7. Signs have to be different. So the big number is going to be negative. 7's bigger than 3. It'll be negative. And the small number will be positive. Next one. Two numbers that multiply to make 14 and subtract to make 5 are 2 and 7. Different signs. Big number is going to be positive. That would be the 7 in this case. The small number will be negative. Here. Two numbers that multiply to make 24 and subtract to make 10 would be 2 and 12. Different signs. Big number will be negative. Small number will be positive. Then there are these down here. Sometimes you'll notice that it's actually not a trinomial. There's a missing middle term, right? We call this the difference of squares. And when we don't see a term in the middle, the same way we saw this positive 3x or this negative 4x, if there's nothing here, we know that means that's actually 0x. It cancels out in the middle. Well, the only way that's possible is it had to have been the same number, one positive and one negative of the same number, like a -7 and a +7 would give you a 0. So when you see these, notice that the back number has to be a perfect square. There has to be some number times itself that equals it, or this wouldn't be true. So we get 2 and 2 in this case, because 2 times 2 is 4, and a +2 and a -2 would cancel out and make 0 in the middle. X squared minus 25, x and x. 25 would be 5 times 5, and a +5 and a -5 would cancel each other out, make nothing there. Next one would be x plus 6 and x minus 6. This one would be x plus 10 and x minus 10. 10 times 10 is 100, and a +10 and a -10 would make 0 in the middle. And then be careful on these last ones, because this only works if it's the difference of squares. They have to be subtracting. That's what difference means in mathematics, to subtract. This is actually the sum of squares that are being added, and this type cannot be factored. Okay? Has to be a minus sign, not a plus sign, for this process to work. Okay, tune in for part 2 and see the backside.